This is 5.1 to 5.4 test review, starting with problem number 4. We are going to rewrite each equation in exponential form for numbers 4, 5, and 6. And to do that, we are going to follow the definition of a logarithmic function, and writing it into an exponential function is going from log with a base of a of x equal to y. And what we're going to do is follow the pattern that is, sorry, let me grab another pen here. We're going to take the base number, a, raise it to the exponent of y to equal our x. Okay? So a to the y, as I have written here, a to the y is equal to x. So to follow that, we are going to take our base value of 11 to the negative 2 power. So 11 to the negative 2 is equal to 1 over 121. And that's written in exponential form. There's nothing to evaluate, no answer to get. All we're doing is rewriting this in a different format. So for number 5, we're taking 7 to the 3rd power is equal to 343. And number 6, 625 to the 1/4. So 625 to the 1/4 is equal to 5. Okay? Now let's go down, and we're going to evaluate each expression here using the same understanding. But here we're equal to some unknown value. And so we're going to use the same process that we did up here to evaluate the expression. So 6 to what expression? So 6 to the unknown exponent will equal 36. And basically you just have to think, okay, 6 times 6 is 36, so that was 2. So our answer here is 2. So same thing here. I'm going to create this box, and we're going to have 3 to what exponent? 3 to what exponent equals 1 over 27. Okay? So, well, because this is a fraction, I should know that my exponent needs to be a negative number. So it's negative something. And now all I have to think about is how many times do I need to multiply 3 times itself to get 27? Well, 3 times 3 is 9, and 9 times 3 is 27. So if I look at the number of 3's I used up 3 3's to get 27. So my answer up here has to be negative 3. And now for number 9, I'm going to create this box here. And again, 3 to what exponent is equal to 243? Okay, well, 3 times 3, as we know, is 9, and 9 times 3 is 27. 27 times 3 is 81, and 81 times 3 is 243. So how many 3's? 1, 2, 3, 4, 5. So I used up 5 3's, so that means my answer here is 5. Okay, so that's converting logarithmic functions into exponential, and then evaluating how to come up with the exponential value if we were to convert this over. But the answer to a logarithmic function is the exponential value of the exponential format. Okay, let's look at number 10. We want to identify the domain and range and asymptote of each of these. So one of the methods that I had discussed in class was that if we have the formula y equals log base a of x minus h plus k, then we would have, and with this, we can determine um, logarithms are the inverse of exponential functions. And so if we were to think about rewriting this into um, exponential, the y value, the input, is what would be the affecting the problem here. So anyway, what I'm trying to get at is my domain now is going to be unlimited because it's the y value that is really the input value. So with the domain and then the range, I'm sorry, the range is all real numbers and the domain is restricted. And since domain is the values of x, we have to look at the h value that is going with the x. And remember, if this was x minus 1 inside, we would be moving to the right by 1 unit. So we have to go opposite of what we see. So when we do that, we're at positive 1, and I need to have positive numbers in here for logarithmic functions. So I need to have x is greater than 1. And my asymptote is going to be a vertical asymptote, and that's going to be x equal to 1. So, or whatever h value is. So change that to h. I'm going off my little example there of why it was 1. So my domain in a general format is that h value. X is greater than that h value. My range is all real numbers. My vertical asymptote is x equals that h value. So right here, h equals 3. Okay, so my domain is x is greater than 3. My range is x, all real numbers. And my vertical asymptote is x equals 3. Okay, so let's take this. Nope, don't want to do that. All right, so I'm just going to erase this and just we'll have to remember it. So what I want to do is rewrite this in a standard exponential format where our base number is 4. And remember, it's 4 to the y equals x. Okay, and that would be rewriting this in exponential format without the shifting. Okay, so we'll make an xy table. But with logarithmic functions, we're going to put in -2, -1, 0, 1, and 2 in for y. And we'll start with the positives, so 4 squared is 16. And so now we're filling in for x. 4 to the first is 4. 4 to the 0, 1. -1 is the reciprocal of 4, so 1/4. And the reciprocal of 16 is 1/16. And when I plot these, I'm going to go 1/16, which is very, very close to the y-axis, and -2. So without plotting that point, I'm now going to be moving. My transformation here is to the right by 3 and down 3. So when I go to that 1/16 and -2, now I have to go right 3 units. 1, 2, 3, and down 3. 1, 2, 3. And that's going to be right there. 1/4 and -1. 1/4 and -1 is right about there. I'm going to go over 1, 2, 3, and down 3. 1, 2, 3, which is going to be right there. 1, 0, and then over 3, 1, 2, 3, and down 3. 4, 1. I'm going to go over 3 and down 3. And I do not have room for 16, 2, so I will not worry about that. And now I'm going to draw my graph. And it looks a lot like it has the same curve as an exponential function, but it's flipped sideways. And honestly, it reflects across the y equal x line. Anyway, okay, let's look at number 11. So my domain for number 11, x equals or is greater than my h value. My h value is just the 1, don't not the negative, it's just the positive 1. So x is greater than 1. My range is all real numbers. And my vertical asymptote is x equal to 1. So now I'm going to do 6 to the y equals x because 6 was my base value. I will make my xy table. I will plug in -2, -1, 0, 1, and 2 for my y. 6 to the second is 36. 6 to the first, 6. 6 to the 0 is 1. -1 is the reciprocal of 6, so 1 over 6. And -2 will be the reciprocal of 36, so 1 over 36. And I will be moving to the right by 1 and down 3. If I go 136, that is extremely close to the 0 line. Down -2. I'm going to go right 1 and down 3. So that's really close there to the positive 1 line. Okay, 1/6 is still pretty close to that 0. And -1, so right 1, down 3. What about there? A little further to the right. 1/0, I go right 1 and down 3. And then 6/1, I'm going to go right 1 and down 3. And 36/2 is not going to fit on here. So I'm going to come up like this and curve over to the right. Okay? And that got me to number 11.